Hello, everyone. I would like to welcome you already to today's exercise session. I see that all of you have entered this big blue button room with not with their microphone activated, but only with the speakers activated. So could you please change this and activate your microphone as well? Because otherwise, as I wrote in the public chat, it's not possible to interact properly, and you cannot really participate in this exercise. So please change this and re-enter the room. Thank you. everyone. I hope all of you can hear me clearly. If not, please let me know somehow. So some of you are in this big blue button room with only the headphones activated and not their microphone. Could you change this? This is because in the exercise, if you have questions or if I am asking questions, then it's not possible to directly interact. So it would be great if everyone had the option to use the microphone in case of questions. And then please mute your microphone so that we don't have any background noise or anything. Okay, good. I think one last student is re-entering with the microphone switched on. So, okay, so today I would like to start with the first exercise with you. This exercise is related to the lecture that I uploaded for you last week as a video lecture. So you have the videos where I'm writing things down and where I'm explaining things and the topics, and you also have the printed lecture notes associated to that, and you have the handwritten lecture notes as well. I don't want to go into detail so much on these lecture notes and what we did in the lecture, but I want to give you an option to ask questions related to this if you have any, so we can clarify those before we begin with the exercise. So if anyone has a question, please write your name in the public chat, and then we can discuss your question. So for those of you who are now still not using the microphone, I think there's some problems entering or using the big blue button with the microphone when you are using the browser Safari. So if you are working on a MacBook, then choose choose a different browser, not Safari, because I know that there is problems with that browser. So if you have any option to enter this room with your microphone switched on, that would be great. If it's not possible, then we cannot change it. But please, if you have a Mac, if you have a MacBook and you're using that for this big blue button session, then please don't use the Safari browser. Use any other one, Chrome, Firefox. Those should work well. But we know that with Safari, it's not working. It's not working well. Okay, so if there's questions, please write your name in the public chat, and then we can discuss those questions. Okay, I don't see any questions coming up right now. So if there is some questions which come up later during the exercise, of course, we can go back and discuss those questions at a later point. So then for now, I would like to switch over to the exercise. And you see this exercise sheet in the presentation that I'm sharing here. So actually today we will start right ahead and go over to some programming. So you have learned the theory basically from the lecture, and now we want to transfer this and study this with some programming tasks, and therefore the exercise sheet that you find in the Moodle course, I will check. I think it should be activated so that you can see. Yes. So I will share my screen. So right now you are seeing the Big Blue Button session, but you should be seeing the Moodle course now. So here you have under the tab exercises, you have here a PDF file which contains the tasks for today, and you have a Fortran file named invarianttheory.f. I will first go, and you have an additional file, Fortran introduction, which is in German. So this study program is supposed to be partly in German and partly in English. We don't have an English translation of this Fortran introduction right now. However, maybe I will be able to provide it at a later point. However, during your first semester, you have taken a class, hopefully, it's a mandatory class in computer languages for engineers, and there you should have learned to use Fortran and know it very well by now. So I hope that you still memorize your programming tasks from that. Maybe we could, I would like to know, do you still think that your programming skills are good or not? So maybe, so here right now I see A, B, and C. So A would be, you think that your programming skills are not so good. B, they are okay. And C, they are pretty good. So maybe you could answer this very quickly so I can get an impression of what the current state is, basically. Okay, so if A is that you think your programming skills are not so good, and C is that they are C is that they are pretty good, and B is that they are quite okay, there's quite a difference here. So if you think that your programming skills in Fortran could be improved, and you want to improve them, I would suggest that you try with this Fortran introduction. Maybe I can, just a second. Maybe I can share this with you for a second and just show you what is inside. So here you should see now the file. So basically what you see here is an overview of what a program should look like, how to read a file, or how to read an input from the screen, how to write a variable to a screen, how to open a file, and there's small examples how to program a do loop, how to program an if clause, and how to compile the program. There's this typical hello world program that you typically that you basically learn in every class that you learn programming. You always do this hello world thing, and there are several other topics such as data types in Fortran. I hope you know that you can distinguish, or you have to distinguish, between integer and real variables. I would suggest go through this. I think there's also options to practice this and to improve this just online on the internet. If you there's some tasks here in the end that you can practice your Fortran with. And as I said, we are working on getting this in an English version so that it gives you some guidelines. And also, I would say you can refer to your notes in computer languages for engineers. So we will be, maybe to give you an outline of the course, so we will start with a Fortran exercise where we will just use plain Fortran and we will compile it using the GNU compiler, just as it is explained here in the in this document. So we will also see this. So you type gfortran in your terminal. So we will do this together during this exercise. Later on, we will go over and use the finite element program FEEP. And this program is written in Fortran, so you will also be using Fortran language there. However, we will not compile the programs just as a plain Fortran program, but we will basically compile the whole FEEP program because there's many parts that go together. We will come to that as an introduction at a later point. You should also know this program from your courses, finite element method foundations. And maybe you're also using it already in a different course, like coupled problems or nonlinear FEM. Okay, so have a look at this file. In any case, I think it can help you. So what I would like to I would like you to do now is download the file tasks that is provided under the exercise section in the Moodle course, and also download the Fortran file invarianttheory.f. This is the one that we will be working with today. And then we will, when you have downloaded this, you can I think it's the best if you download it directly in your Ubuntu desktop. So you can also use so what you all should be able to do is use the VMware and basically open this Ubuntu desktop under your own username. So therefore, you need to use the VMware Horizon client and prepare the related server. So there was this introduction given in the Moodle course, and I ask you to do this as a preparation for this course. So is everyone able to see or to start this Ubuntu desktop on their own through the VMware? If not, please let me know. I know that some of you had some problems with this, so maybe just yes.
Hello. Yeah, I only have Windows 10. Like I got a Windows.
Okay, probably this. I think this might be a common problem. So if that is the case, please check that you are using the correct servers. So I'm posting now in the public chat. I'm posting the server names that you should use. Probably, if you have used the instruction that you find under the link that I provided, it tells you that you should have some server client named. Or if you go through the, I think it's if you go through the CIN, then you have some server name VDI.external or something. The ones that you should use are the ones intern.cvis.uni-dur.de. If you are in the VPN network, or the same one that you see here with extern.cevis.uni-dur.de when you're not in the VPN network. Have you used these? If you haven't, then please try with this. And also for the rest of you, if you can only see Windows 10, then it's most likely that you are not using the correct server. So you should use the servers that I just posted in the public chat. And with those, you should be able to open the Ubuntu desktop and see basically what I'm seeing. Maybe you can just quickly write a note in the public chat that it's working, whether it's working or whether it's not working. Okay, I'll wait a few minutes so all of you get this set up. If you have it set up already, then I think it's the best idea to open the Firefox in this Ubuntu environment and download the files from the Moodle course there to have them right there, so you don't have to transfer back and forth with your from your laptop. So please let me know. Maybe you can hit the yes button if you have succeeded in opening the Ubuntu desktop and also downloading the files. That would be great. So I know that everyone is all set to start.
Yeah, it works.
Okay, great. Okay, I see that most of you are able to start the Ubuntu desktop and that you have downloaded the files. So in that case, I will open. So just give me a second to organize myself. So I would like to go through the exercise file and the program, the Fortran program code that I uploaded, and go through and discuss what needs to be done, basically. So I will stop sharing this screen. Actually, we can go through the tasks here with the presentation that I uploaded. So we have in total 3 tasks. Basically, these tasks are small exercises where you need to use the Fortran code that you have programmed before. So before you can start to solve these tasks, you need to complete the missing subroutines in your file invariant theory .f, which are named eValue and dyadic EV. So I will therefore share the Fortran file with you. Okay. Okay, I hope you can see this well. So I made the lines. I just changed the size here in this document. Okay, so the whole program is called, you have the main program here, which is called invariant theory, and it can be used to basically solve the different exercises. So we have some variables here that will be used throughout the subroutines and in the program. And with this switch, you can switch between the different exercises. So any x equal to 1 is exercise 1, equal to 2 is equal to 2. You will see during or in this program how this where this goes. So first of all, every exercise needs a matrix, so therefore we call the subroutine, which is named read underline H, and then in the first step, this matrix that is read here in this subroutine is written to the screen. So I will go over this and go right to the subroutine that you see here. So this subroutine is called, and this subroutine here basically has only two variables, which are a 3x3 matrix named H and a small perturbation that is needed in one of the exercises. And then here you are able to insert the data for the matrix that you will be using. So, for example, in the first exercise, you will need to use a matrix which has the entries 960, 096, 004. So that means you would have to insert this matrix here, and then it can be read in your program. Okay, so no matter what exercise you are doing, you are first reading here this matrix, and it's being written to the screen. So if we are in the first exercise, what is being called is the subroutine exercise 1. For 2, it's exercise 2, and for 3, it's exercise 3. And those do different things. So for example, here, in exercise 1, if we look at the exercise sheet, it says you're supposed to compute the eigensolutions, which are made up of the eigenvalue and the eigenvector for the matrix H that is given, and you should compute the principal invariance. And therefore, you can use the subroutines eValue and dyadic EV. eValue is computing the eigenvalues, and I think the invariance, and dyadic EV is computing the it's taking the invariance and computing the dyadic product. So Ni dyadic Ni, or N1 dyadic N1, N2 dyadic N2, and so on. So the dyadic product that you have based on your eigenvectors, and which also occurs in your spectral decomposition. So I want to switch over to the subroutines. So here in the here you have the subroutine eValue. You have here several tolerances. So first, of course, you have your declaration of your variables, and also a short description. So this subroutine computes the eigenvalues of a 3x3 matrix with 3 distinct eigenvalues using Cardano's formula. So we have learned about this formula in the lecture. And actually, Cardano's formula is what you should be computing here in this subroutine, and what you should be programming. So first of all, it starts with the task where you should compute the principal invariants, which are I1, I2, I3. I hope you remember the definitions. Otherwise, you can check in your lecture notes. And as a second step, you should be computing the discriminant delta. And here again, the formula is given, but you also find it in the printed and also in the handwritten lecture notes. You remember that based on the discriminant, we could evaluate whether we have three different eigenvalues, or whether we have two eigenvalues that are the same basically, and then one other one. So basically we have two eigenvalues only. So this can be distinguished based on the discriminant, and therefore this if clause here is realizing the different cases that we are looking at. So the delta is the discriminant, and P is here the part that gets the power of 3. And let me just open the lecture notes quickly. Yes, P and Q are the coefficients which you find in equation 313 in your printed lecture notes. And with these, you can distinguish. So first of all, you check whether your discriminant delta is smaller than a certain tolerance. So here you do not evaluate against a tolerance equal to 0, but you evaluate against the tolerance 10 to the power of -8. This is what you typically do to make an algorithm stable, because the computation, so in this case, it can be explained as the following. Even if your discriminant delta has it's not exactly equal to 0, but it's like it has a very, very small value, very close to 0, then also you have an instability in your evaluation of Cardano's formula, and your result of the eigenvalues will not be correct. So this is why we are not using 0 here, but we are using this very small tolerance, which is given here by 10 to the power of -8. And then we are evaluating basically the cases that you have written, or that we have discussed in the lecture notes. If you want to, we can go through this together. It ends with the evaluation of the eigenvalues by back substitution. Okay, so this is here you need to program the respective variables that are given for Cardano's formula in your code. So the variables names are the same, so it's gamma and alpha, just as in your equations in 314 and 315 in your lecture notes. And then these first EV1, EV2, EV3, those are the eigenvalues with the tilde. That's these three. And after you have checked the sum and checked that the sum is equal to 0, you can evaluate the eigenvalues by back substitution. So this is basically a realization of what we have learned in the lecture under the name Cardano's formula. we also had a formula given in the lecture notes for the computation of the dyadic product, and this is what should be programmed here in the subroutine dyadic EV. So here, if you look at the lecture notes, so in the printed lecture notes, it's on page 25, and the formula is in equation 335. You have to compute part of your formula. You have to compute the adjungate of H. So this is one part that you have to realize here, and then you have to basically insert the formula here in this do loop, which you have to realize on your own. And with these two subroutines finished, then if you run exercise 1, then you will get the result. And 1 second. Yes, so here exercise 1 is called. So after this subroutine has been evaluated properly, then the result, the invariance, the eigenvalues, and the dyadic products are written to the screen. And if you have finished this, we can compare with the results that I have for the respective matrix. Exercise 2 contains. There we go. Exercise 2 contains the programming of the Cayley-Hamilton theorem. And therein in exercise 2, you should be computing the expression, an expression of the matrix polynomial h to the power of 4 for the given matrix H with the entries 3, 1, 0, 1, 2, 0, and 0, 0, 1. Therefore, you need to program everything basically that is necessary to evaluate this based on the Cayley-Hamilton theorem. Exercise 3 is related to what is named, what is under task 2 with a 3 in brackets, where you should be computing the sine of a matrix H and the cosine of a matrix H based on the Taylor series expansion as you have given here, and also evaluated based on the spectral decomposition. So this is the first 2 exercises, which is basically exercise 1, 2, and 3 here in the program, in this Fortran subroutine. And then the third task that is related to basically the first exercise using the evaluation of the eigenvalues and the dyadic product. So that does not have a separate exercise here in the program sheet, but we can use one of the exercises to evaluate this. So this we will do at the very end. I hope that my explanations were clear. Okay, we have also one function, because in some evaluations you have, in some of your formulas, you have to evaluate the faculty of a number, and that can be done here with the function faculty. So when you are calling this function with some variable, this is interpreted as a real variable, then it returns you the faculty of this variable. Okay, so I would suggest that you have a look at this program invariant theory on your own, and if you, maybe we can do it in such a way that if you have questions related to this, then then we will discuss them here in the Big Blue Button chat or in the Big Blue Button room. So maybe take 2 or 3 minutes and go through the problem tasks on your own in the PDF file, and also have a look at this Fortran file. Then we can discuss your questions together. And then it is your turn to start the programming and filling in the blanks in the program invariant theory. Is that okay? Does anyone have any remarks? Okay, so then if everything is clear to you and you know what to do, then please hit the yes button in the question tab that I opened, and then we can start quickly on the programming. Or if you think that everything's clear, then you can go right over and start to fill in the blanks in the program invariant underline theory. And I would suggest, as it is written in the task sheet, that you start to fill in the missing, or to complete the missing subroutines evalu and dyadic EV in the Fortran file. I think that's the best to start, because without those subroutines you cannot complete any of the exercises. Okay, so if you have trouble, first I will give you a few minutes so you can check out the files on your own, and if there is questions, then we can discuss those in the Big Blue Button lecture room. Okay, so I ended the poll, and I think 4 of you said that you know what to do. If anyone else does not know what to do right now, please let me know in the public chat or unmute your microphone and let me know. So now comes kind of a difficult time phase in this online teaching, because it's not like in the zip pool where I could just walk around and see how you guys are doing and answer questions and check on you whether everything's going okay. So this is really not such a nice situation. I would suggest that so this program task should be done on your own, and I want to give you some time to try this on your own before I show you what should be done and fill in the blanks in the final program. And I would like to do this in such a way that if you have questions, then you can let me know in the public chat. You can also, there's the possibility to send private messages. If you click on the participant here, you can start a private chat and ask questions. So you can use whatever option you want. You can use your microphone, you can use the chat, you can use the private chat, you can do anything that you want, but please, if you have questions, let me know and let me try to clarify those questions. Otherwise, I will give you now some time to complete the first task, this part where you should be filling in the subroutines evalu, or you should be completing the subroutines evalu and dyadic EV. So I would say in around 30 minutes, I will give you 30 minutes to do this on your own, but I will remain, of course, here in this room to answer questions. And in around 30 minutes, I will start to show you how this what should be programmed. Okay, so then I will show you here in the big blue button screen what should be entered in the blanks. Okay, and again, if you have questions, it's really weird not to be able to see any of you and to get like a nodding or some response. So if you have questions, please let me know in the public chat so that we can clarify those. Okay, I would like to make one more remark because I'm not sure whether I made this remark in the first lecture. So during this course, we will do programming exercises, and there will also be a final project at the end of the course. This is a way, it's not mandatory, but it's an option to improve your grade. And in addition to this project, so if you want to improve your grade, your final grade, so in addition to the final project that can improve your grade, you can also improve your grade by handing in your program codes from the exercises with a short documentation of the results. So the finished code, as well as just a text file with the results of the exercises can help you improve your grade. So you can gain some extra points with that to improve your grade, your final grade in the exam. So to get those points, you have to basically hand in all of the exercises. So if you only do that for one exercise, that won't be enough work to improve your grade finally. But if you do this for all the exercises, then and you get the correct results, then this will give you a chance to improve your grade. I just wanted to make this announcement because I think we talked about the projects in the first lecture, but not about the possibility to hand in your exercises. I will also make this announcement during the in the Moodle course. So I think a good idea would be if you hand in, today we have the exercise, and you will be able to send me your exercises until next Thursday, or basically Wednesday before. So you have 1 week approximately to finish your exercises and to hand them in. Of course, if maybe we need 2 weeks for one exercise, then this deadline gets extended, but you will be able to hand in your results 1 week after the exercise has taken place online. I will make this announcement in the Moodle course. So for today's exercise, you will have at least the coming week to finish it and to hand it in. Okay, so as I announced, I'm back half an hour later. So I created a poll in which I would like to know about your current state of the programming. It would be great if you could let me know through that, or if you write a message, or if you unmute your microphone, whether you could just let me know what your current state of the programming is, so I know when to continue with the results.
Hello, ma'am.
Hello.
Actually, we had a problem with while typing. Actually, our keyboards are normal English, and VMware is Ubuntu is German. So we had a little bit problem with typing.
Okay, with it. Okay, what was the?
It is taking a little bit more time.
Okay. Okay, if it's just about the time, then this is fine. So I mean, with the English and the German version of the keyboard, I know that the Z and the Y are exchanged. Was that the problem, or what is the problem?
No, the other symbols are also.
Other symbols are not working properly. Like in German keyboard, it is in somewhere placed like is equal to plus and brackets, braces.
Ah, okay, that's the problem. Ah, okay.
Is there any way we can change our keyboard?
Sorry?
Is there any way in Ubuntu we can change our keyboard to English version? Like in Windows we can do that.
I think we can't change. The Ubuntu.
I don't think so either. I would have to. I can ask the people who are doing the support for the Ubuntu desktop, and I can ask them whether there is an option to change this. But I'm not aware that there's any option to do this. Let me see whether. No, I don't think that you can really change any settings.
Yeah, actually VMware we can't change anything.
Yeah, I think so too. Okay, I will still get in contact with the people from the support for the Ubuntu for these VMware Horizon clients, and ask them whether there's an option to change this, because I understand that if you're used to a different keyboard, then it takes additional time. I will let you know in our next exercise. So I will make a note to myself to do this. I would like to make one remark for your programming. If you would like to test your program, maybe only with the first exercise, you will probably run into problems when there is some question marks in your program code and you are trying to compile this program invariant theory. What you can do is that you simply put a comment to everything that you have not worked on yet. So if you just comment all the subroutines and exercises that you are not working with in exercise 1, then you can compile the program invariant theory and check your results whether your subroutines evalu and dyadic EV are working. And you can also beforehand check your subroutines evalu on its own. So you just need to, if you compile, it will give you an error because it cannot interpret the question marks that are here. So simply if you put a comment to everything that is not filled in yet, then this should do, and you can compile your code. So here on the bottom, you basically have this commented. What you simply would need to comment additionally is, I think, this part here for evalu for the eigenvalues here for the dyadic product. For Cardano's formula when you are evaluating this. So otherwise you can simply run this and check whether you get some compiling errors, because that could also be a problem. Okay? So if you run into problems while you are compiling, please just let me know. You can post your the error that you see on your screen. You can post this into the chat, and then we can try to figure out what is going wrong. Again, if you have finished your subroutine evalu, or if you have finished the subroutines evalu and dyadic EV, then please let me know through the poll, so that I know how far you have gotten and when to continue and explain things for everyone. so I posted another poll in which I would like you to answer, so I know what is the current state, whether you just need more time, whether you need more advice, or whether you have finished the programming already. So please take a second and answer the poll so I know how far you have gotten. If you have finished the subroutines, then and the exercise 1 is working well, I will show you in the shared screen the result that you should see. And then you can compare, and if that works, and if you get the correct result, then you can simply proceed to the next exercise. If you have questions related to anything, just let me know. So for exercise 1, what you should get as a result is what you see in the terminal in my shared screen. It could be that your values are differing just a little bit, but in general, they should go into the same direction. So you can compare here for the invariance and for the eigenvalues, and also for the dyadic product. But especially here, I mean, this is basically 0. So if it differs in some of these digits, that is just due to the numerics, but it shouldn't differ so much. So if you consider this 10 to the power of minus 15 to be 0, then your values should give you the same. Okay, so I know. Okay, so I know that some of you are having problems when compiling and running the program. I will make a comment on that or show you some error that might occur in a second. And then I will go through the programming for eValue and dyadic EV, and then I would like to discuss some first results with you. Okay, one remark for everyone, because this problem might occur not only in one case, but in multiple cases.
Sorry. Hello?
Just 1 second. are some problems for some of you with saving the files, please make sure that you save your files in your Z drive. So you find in your in this in the program which shows you all your files, you find the Z drive, and here I have multiple files, but be sure that you save it in the Z drive. In maybe if you open it directly, it will try to save it in the temporary folder, so that is not possible. So in some way, create a folder where you save all your exercises, just in the way that I did here. And then another thing that I wanted to show you, because I was talking about putting a comment and commenting lines, uncommenting lines, you can create shortcuts for that. Maybe they are created already. So what you do is you click on Help and Keyboard Shortcuts, and then you see the shortcuts that are created already, but you can also edit this and change the shortcuts that there are. Okay, so for example, I created a shortcut for commenting lines and uncommenting lines, because this can be quite handy not to have to type a C in front of every line. Okay, so this was the first remark. Another remark, you can compile your program. Here in the Genie directly. You can use the G Fortran compiler or the GNU compiler by typing the line that is given in the exercise in the terminal. If you find that there is an error here, this is most likely because of the of this function. I think in some cases this error occurs, in other cases it doesn't. But you can simply change this command dint in line 520 to idint. Okay, this is creating out of the variable that is inserted, in, it is creating an integer, and that is put into jend, and then you can use it, and your compilation will not break at this point. Did anyone have problems with this while compiling? Okay, I assume that, so it's really difficult to know how far you have gotten. So I know that some of you are still working on programming. Some of you have finished evalu and dyadic EV. Some needed more device, and we discussed some things in a separate video chat. So that is also an option. Does anyone have trouble to finish, or have you all finished the subroutines evalu and dyadic EV, or do you have some specific questions that we should discuss right now? To answer my question, please type in the public chat or unmute yourself and just speak in this room. Okay, there's no responses, unfortunately. Okay, I will go over and explain or show you the results that you should have for the subroutines dyadic EV and evalue. Probably if we do not get to the end of this exercise, this will be the homework for you. Of course, if you have trouble to finish the programs, you can always come to the, you can always send me an email after this class, and you can also come to the consultation hours. I got notice that the consultation hours overlap with another course, so I will shift the date, but I will make an announcement in the Moodle course on when this consultation hour is shifted, but also an email at any time is also fine, and then we can arrange an online meeting. Okay, so what we want to do is compute or fill in the blanks that are missing for evalue and dyadic EV. And I think the first parts are not so difficult if you are not having trouble with your keyboard. So what you should have what you should compute here is the principal invariance. So you always need to make sure that the variables that you are using are also defined in your subroutine or your program. So in this case, I will be using I1, I2, and I3. And there's multiple ways to compute the trace of H, but I will use the, I think, most simple one. So simply add the terms on the main diagonal. So this should be it. For I2, I will be evaluating the trace of the cofactor. So here we have the trace of the cofactor. And for the third invariant, we have the determinant. And I think all of you know how to compute the determinant of a matrix. And this is how this should be done. Next, it is asking you to compute. If I'm going slow in my speaking, it's because I'm trying to have a look on whether there's any response. Ah, okay, you want me to increase the font size. Of course. Yes, I hope you can see it more clearly now. So this is simply the evaluation of the trace of H, the trace of the cofactor of H, and the determinant of H, which are the principal invariants of the matrix. Next, the discriminant should be computed. And the formula for that is Q squared plus P to the power of 3, where Q and P were given in the lecture for Cardano's formula. So what you simply need to do is you need to type in the formula. This should not be too much of a problem. And here you see one very important fact in Fortran, in programming in Fortran. You need to, if you want to use real numbers, for example, if you want to say 3 times I2, you need to write this as 3.d0 times I2, okay? This d0 here is very important, because if you don't specify the decimals after the comma, then it will just take some values from the disk memory. Okay, so and that can increase. That can be the reason for computing errors and differences in your results, basically. So if you want to use the number 3, then you need to put 3.d0. I think this is something that you learned in your previous Fortran code courses already, but this is an error that is done in every course, basically. So please be aware that if you want to use just numbers like this, you always need to put .d0 behind the number. Okay, and then delta can be computed here by q squared plus p to the power of 3. I think this is clear. This should be clear for everyone. This is quite easy. And now it comes to this if clause, which is taking care of the different cases of the discriminant. So we want to consider cases where we have delta less than 0. So this case is handled here in this if clause, and you see if this is not met, then your program will return that your variables are out of range, so it will not be able to compute the values based on Cardano's formula. So you are checking here that the delta is smaller than your tolerance value, and that p is less than 0. This sign of q is, together with this if clause, it is computing basically the sign of q, as the name says. So you are setting sign of q equal to 1, and then if q is less than 0, sign of q is set to -1, okay? So if q is negative, then this will be -1. If q is positive, then this if statement will never be met, and sign of q will just be 1. So going further, because you need sign of q and also the root of the norm of p in your computation of gamma, what you are next defining is the helper variable x1, which is the root of the norm of p, and x13 is then this term to the power of 3. So this is used, this x13 is used in alpha, and this x1 is used in alpha but also in gamma. If it happens that this x13 is smaller than, is very close to 0, then what would happen in your equation 315 is that you divide by 0, and that will give rise to numerical errors. So if it happens that your value, your absolute value x13 is very close to 0, what you do is you simply set it to your tolerance. So if it's less than the tolerance, you set it to the tolerance to have a limit for this value close to 0. Is that understandable for everyone? Does anyone have questions related to this? if that's not the case, I will proceed. For gamma, we know from our formula 315 that it is equal to the sine of q times the root of norm of p. That means, in our case, it is simply the sine of q times x1. Alpha, we know, is equal to 1 over 3 times arc cosine or a cosine of norm of q divided by the cubic root of the norm of p. Or sorry, not the cubic root, the root cubed. So that means we have dA cosine. We are using d because we have real variables here. Absolute value of q divided by the cubed root of the norm of p divided by 3. And then the eigenvalues, the tilde eigenvalues, our temporary values, are computed by these formulas. So again, here we are using this cosine function with the d cosine because we are using real variables here, real star 8 variables. This is simply the evaluation of equation 314. Next, we are checking whether x1, the sum of all the temporary eigenvalues here, lambda tilde, are equal to 0. So if they are greater than a tolerance, then we are told by the program that we get an inaccurate solution. Otherwise, if this condition is met in 316, we can compute our eigenvalues by back substitution. And back substitution simply gives us this result. So lambda I is equal to lambda I tilde plus I1 divided by 3. Has everyone finished the evalu program so far? If not, then please write in the public chat. Okay, I see that 2 of you have done this. Okay, I'm getting weird results because I'm using the wrong matrix here. So you can already evaluate you can already check whether your program is working correctly. So I'm compiling here using this command. I don't know how to increase the font size in the terminal, unfortunately. I hope you can still see this. So it's gfortran -o. So the output that I'm creating for the executable is run. The name is run test. And then I have the name of the Fortran file, which I want to compile. And it's not giving me any errors. And run test I can run by simply typing // and then the name of the file. And here I am computing the, so the dyadic product, this is incorrect still because I didn't finish the subroutine, but here for the eigenvalues, I hope this is correct. Yeah, so it is the same as we get for the correct solution, which I saved in the executable run test. I hope everyone gets also these results. For dyadic EV, okay, so if you have questions related to the subroutine E-value, please write them in the public chat. If not, I assume that all of you have understood what we have done here. And I will start to explain for the subroutine dyadic EV. So here, we want to compute the dyadic product of the eigenvectors based on the formula that is given in the lecture notes, which is stated in the in equation 335. So there you also see that that you can reformulate this based on the equations given in 334. And to evaluate this, we need the adjungate of H. And we know that the adjungate of H is the cofactor transposed. So we can use the formula for the cofactor and simply transpose this. And you find those formulas in the lecture notes. So here, this is simply evaluated for the matrix H now. And for the dyadic product, there's only the loop here given. And there is several variables given here or there's two variables given here, x1 and x2, which are helper variables to help you compute the dyadic product. If you look at the formula in the lecture notes, I cannot share an additional screen, so I will just hope that all of you are able to look at equation 335. So there you see, for example, that you have this fraction in front of the bracket term with a matrix H, and this fraction here. For that, we need to make sure in our code that in this fraction we do not divide by 0, okay? And this is what we use the helper variables for. So in the beginning, or in the first place, or in the first statement in our do loop, we do this for every eigenvalue that we have computed. So first of all, we define x1 as the value in the denominator of this fraction, okay? So it's 2 times eigenvalue EV I. So the eigenvalue squared minus I1 times the eigenvalue plus I3 divided by the eigenvalue. This is simply the formula that you see in this fraction in 335. Okay, so if we know this value, we can use an if clause to do the same as we did in the previous subroutine. So what we do is we check whether, this value x1 can be positive or negative, but the problem is when it's very close to 0. So we check whether the absolute value of it is less than a certain tolerance, and this tolerance is 10 to the power of minus 8. So if it's between 10 to the power minus 10 to the power of minus 8 and plus 10 to the power of minus 8. It's too close to 0. And then we simply set x1 to 0, or not to 0, sorry, to the tolerance, okay? So in the case that this denominator is 10 to the power of minus 10, it will be set by this if clause to 10 to the power of minus 8. And then in our next line, we are evaluating the fraction that we have in our statement. So now we say x1, our helper variable, is equal to the eigenvalue EVI divided by x1. So this is all of this is the evaluation of the fraction that we have in front of the bracket term in 335. We are using then the second helper variable, x2, to express the bracket term I1 minus lambda I in the bracket term in our expression. And what we do next is we evaluate the dyadic product. And here it's important to note, okay, I see that someone is typing. I will just wait for a second. Can I repeat the if part? Yes, of course. So this is the denominator part, okay? So if you compare with your formula 335, you will notice that this is simply the denominator term. I will do one second.
Yeah, actually I got that part. Then
Yes.
yeah, I am like referring to the script as well. Yeah, I understood that that's the denominator, but why are we using that if part, like the tolerance thing, and that I am not getting.
Okay, so I mean the problem is if you are one second, I'm having trouble to share my screen. Okay, so the problem is, I mean, if you understood the if part, you are, the problem is if you are trying to divide by a number that is very close to 0, your fraction will go to infinity, okay? Any value divided by 0 will go to infinity, and that gives rise to errors in your code, and this is why you need to limit this by setting, if it gets very close to 0, setting it to a tolerance value. Okay. Okay. So I wanted to explain now about the dyadic product. So the dyadic product here is saved in a matrix which is 3-dimensional. So if we consider N1 dyadic N1, N2 dyadic N2, that is simply a 3x3 matrix. But because we want to save the 3x3 matrices in one variable, we have here the variable xn, which is 3x3x3. So we will be saving in the last column. So this last 3, that is referring to the I, okay? So in the first 3 by 3, we will be saving the matrix, and then this last index here is referring to the eigenvalue I, lambda I, that we are computing this for. So now we need 2 loops to compute this dyadic product with, and we have j and k left for the variables, for the counter variables. So for j equal 1 to 3 and for k equal 1 to 3, these will be the variables for computing now the bracket term. And now, so I will do this slowly so you can follow. This is now equal to x1, which is the prefactor term that we have multiplied with. In our bracket term, we have h minus some bracket term, which we saved in the variable x2 times I, plus 1 divided by lambda I times the adjungate of h. So what we do here is we multiply that by h, sorry, that should be jk, plus the adjungate of h, j comma k, divided by EV of I. Okay, and now you might say, oh, you missed a part. I'm doing that in a different format. So now I'm saying I'm considering only the main diagonal and here I'm subtracting x1 times x2, okay? Thereby, I don't need to introduce a variable for the identity matrix. I simply consider this in my program, in my loops, because I only do this for the main diagonal, because I say I do this for j, I, and I do this not inside the k loop, okay? Okay, I think I have 1 and 2 to, this is the end do for the I do loop. So this should be the complete code for the dyadic product. And I hope I didn't make any mistakes, so I will try to run it. Okay, and I was able to run this, and it gives me the right result. Okay, so there's a question, why is it x1 times x2? Let me go back to the, you mean this, right? x1 times x2. This is because, so in x2, it's my expression I1 minus lambda I. Because you need to, okay, why it's not just x2? Because you need to multiply with your prefactor. You must not forget about your fraction that is in front of your bracket, okay? This is what the x1 is for. Okay, so this basically is taking care of the fraction that is in front, which is this kind of lengthy expression, times the bracket term in the larger brackets, I1 minus lambda I times identity. And I'm not introducing the identity tensor, but I'm simply just subtracting it on the main diagonal, okay? Okay, so this would be the realization for the eigenvalue computation and also for the dyadic product of the eigenvectors for that computation. And that is what we wanted to compute for the first exercise. So we didn't get quite far in this exercise today. So the second exercise is on the computation of the Cayley-Hamilton theorem, and the third exercise is on the computation of the cosine. I would actually like to give this to you as a homework, because I don't just want to give you the results. You have all the formulas that you need to fill this in your lecture notes. You have them in the handwritten lecture notes and you have them in the printed lecture notes. So what you need to fill in is this part in the exercise 2. And here you are comparing. So here it says you have the direct computation of h to the power of 4, and then you are computing h to the power of 4 using the Cayley-Hamilton theorem. So here you are simply doing h times h times h times h in a matrix multiplication way, of course. And here in this part, you are evaluating it using the Cayley-Hamilton theorem, meaning that you have a polynomial of order 2. So that is what you need to fill in for the Cayley-Hamilton theorem. And for exercise 2, and in exercise 3, what you should do is you should use the result that you get from this, or you use the subroutines evalue and dyadic EV to evaluate the sine and cosine functions for a matrix based on the spectral decomposition. So this is also related to the to what we did in the lecture. So here you should simply realize this in a computer program. Yes. Okay. So what I would like to do, what I would like to give you as a homework is finishing the exercises. Whoops. Sorry. Exercises 2 with the Cayley-Hamilton theorem, and exercise 3 and 3b. 3 being, sorry, my mouse is going crazy here. 3 is about expressing matrix functions based on the spectral decomposition. And so is 3b. Wait, sorry, no. No, yes, it's the same. I'm confused. Just 1 second, please. Okay, in 3B you are using the spectral decomposition, but just to express the variable h powers here in terms of the spectral decomposition. It's all explained in the exercise sheet. I will share that. So in the exercise sheet, this is task 3. Where you are computing the, so here you are computing the sine so you are computing the sine and cosine of h based on this Taylor series expansion. And furthermore, in exercise 3, you should compute it based simply on the spectral decomposition. So cosine of, so to express cosine of, let me type it in the public chat. So cosine of h is then the sum from I equal 1 to 3 times cosine of lambda I times ni dyadic ni. As you have given in your lecture notes. So there we also have for the matrix functions, we have the exponential function of h in 350 expressed as the Taylor expansion, but we also evaluate it as the exponential function just based on the eigenvalues. Okay, so that I would like to give you as a homework, and there will be a consultation session next week in which you can ask questions related to this. I will not upload the results, the final results, because this is, then you could just copy it and hand it in. So since you earn extra points by submitting your exercises and the results by sending them to me, you can, and if they're correct, you can earn extra points. So thereby, if you have questions, you can write me an email if you have problems, or you can come to the consultation hours. And also, if there's questions right now regarding the tasks and the homework, then we can also try to clarify those right now. So is it clear for you what you should do as a homework? Do you think this is, so are your programming skills sufficient to do this, or do you think this will be a large problem? So it should be, maybe to say this in advance, your programming skills should be good enough so that you can finish this. And it takes maybe some time and study of your lecture notes to finish this. But I think with the lecture notes and with your programming skills that you should have at this point of your studies, you should be able to do this. But still, I would like to know whether you think that this is too hard for you to solve, or whether it's a task that is okay, just to get an impression of the level in this course. Maybe you can type your answer in the public chat to let me know. Okay, great. That's good to see that all of you think that the difficulty level is okay. Again, I will make an announcement on when the consultation hours will be, because I was told that they interfere with a different course. And then if you have questions, we can discuss them then and go into detail on the problems that might occur in your programming. If it's a Fortran related error and your compiler gives out an error message, it always tells you where the error is. In Genie it does, but also if you just compile it with a Fortran compiler, it tells you where the problem is. Okay, it tells you the line, so you can always start to work from that point. And if you attend the consultation session, in the Big Blue Button session, please make sure that you switch on your microphone, okay? Because that makes things a lot easier in the communication. Okay, so we are a little over time, but I think actually if that is okay with your schedule, I might use if we do exercise sessions, I think it's a good idea to extend the time a little bit, because it just takes more time to discuss and organize everything in this online mode. However, I think these online exercises help you to understand the topics of the course. If you have any suggestions, if you have any remarks how I can make things better, then I would be happy to get those remarks from you. If something's not running well, I will talk to the people from the computer lab whether they can, whether the keyboard can be changed, and maybe we can also find a different option to interact so that we can share the screen by another program. But I will tell you about this in the next week. Okay. Yes.
Actually, the presentation hours you wrote that Tuesday, but we have the couple of classes also on that.
Can you repeat that? That didn't come in clear for me.
The consultation hours are on Tuesday.
Yes.
As in the module, but we have the couple problems classes, lectures also
yes.
on the same day. So maybe this. So what about this? This time the consultation, like the next week. So when it will be?
I mean, so it's always. I mean, you don't have you have classes all through the throughout the week. So I will check with your schedule.
I think Wednesday we are free. I think
Yes. The thing is, okay, we can. Okay, let me check my schedule on Wednesday. Okay, we can change the consultation hours to Wednesday morning. Is that suitable for all of you?
Or maybe we can make it later on Tuesday if it's possible.
Tuesday afternoon, you mean?
Yeah, because till 1 o'clock maybe we'll be finished with our classes.
Okay, then Tuesday at 2 o'clock. Let me see. There's next week. Okay, Tuesday at 4.
Oh no, 4 I have language classes.
Okay, I see that this is difficult. Okay, my suggestion is Wednesday at 9, because I have during this I mean, in the same way that you have your online lectures, I have multiple appointments where I have to meet people online, and those are basically throughout the week. But I could suggest Wednesday at 9 or even earlier. I mean, Wednesday at 8:30 would also be fine with me. Okay, you know what? I will make a doodle poll, and then we can discuss what time is most suitable. So I will create this poll in Doodle right now. I will send you the link through Moodle, and then you can answer. I will evaluate this Doodle poll on Sunday, so you can write your suitable times until Sunday, and then I hope that we find a time that is suitable for all of us, because I know you have classes and maybe you have part-time jobs that you have to attend. So I will send you a doodle link, and then I will make a statement on when we will meet with the consultation hours in the Moodle course. Because I think now in the chat it's going it's too confusing to find a suitable time now. So I will send you a doodle link. You will receive that in a few minutes, and then you can answer, and then we can decide on when to meet in the consultation for the online consultation hours. Okay, if there's no further questions right now, then I would close today's exercise session. I'm glad that so many of you attended, and I'm happy that you all participated in this exercise. It was at least a little bit like a live exercise, although it's not really coming close to exercises and lectures in presence, but that is the case how we have to do it right now. So thanks for your participation, and I hope to see you either in the consultation hours next week or in the lecture. So have a good rest of the day, and see you soon. Bye-bye.
وما في مي بتغلى على الغاز.
You are currently the only person in this conference.
وين السند؟ وين القلب؟ الطريق القلب. طيب اللي انا اخذكم من السبت. طب ما هذا بسيط بنشوفها. الناس شوف رزق انت للسبت، شوف رزق. هي ما فرقت يومين يما، فرقت يومين ما يكونش رايحة. ايه يعني بالقاعدة قاعدة. هات انطيني الكسرة. بس يجي استنى شو امد اخذ. هات انطيني. دي ناس مسكينة يما. ودي فوقني كل يوم يا شو قاعد برجع لك شو اللي رنك. قاعد برجع لك. هات الكاميرا والله بجيب لك الكاميرا. هات من هنا. يما ردي. الناس ردي. الو. الناس ما بسولف. السيف منطقة شيل خلنا نروح نقلع قبل ما يتخرب. تعطيني الصبر بس. تعطيني الصبر. يعني شو فرقت السيف بدك تخبريني يعني شو يعني؟ ودي شو فرقت؟ انا فرقت يومين انا مش طايق حالي. قاعد برجل فيه لليوم. صار لي اسبوع برجل فيه عشان الخميس بس عشان الحصل. وكيلك كيف كيف وبعدين شو والله شو والله وهاتي 25 ليرة. شو اي وهات 25 ليرة. انا مزعل عشان هاتها ورزق العناكات. بنطيك شيء والله ما بنطيك شيء. اي الدفتر اجي اعطيني الدفتر. انا شو بدي فيه؟ تلبسه؟ بعدين خاتمين مش خاتم. مربع اثنين مش واحد. ترى ما اكتسب على اللي سجلته كل شيء اول واحد. لانه بسجل الصندوق لا بخربطه ولا شيء. لانه اصوات الله هذا ساعات خربط. داروا الصندوق وما خربطوش نقوا من فوق. يعني مين اللي كسبها؟ اللي سجلته كتب. بس ان شاء الله نظف بخربط. هذه بدل خاتمين بعد. وهاي اما اذا بتسكنيش اصير اني اجرجر بالشارع. هاتي هاي 5000 مفروض. وين بشيلها من هاي للسوق بشيلها. حبيبي وهبدا تكون وانت ايش تسوي انطيني هاتي مفرش ما خفيف مفرش بس قد الدنيا. شو احنا بدنا ياكل شو قد الدنيا. شو بدي فيه بعد؟ احسب كل واحد ايش اشترى 25 تحت. هي 43 كيلو ماما الشنطة مش كبير بطل مش كامل خفيف. كيف النوعية؟ الكينية يبغى نوعية حار. كملي يلا. ليه خليني بس ارتشف مي واجيك. بالله عليك اروح عليه الشعر ممكن صح؟ هيك عادي ترضي. تحمم. انت شو بديش اتحمم بس شو اللي تفهمني؟ هاتي وين قمر؟ هاي قمر. طب روح اتحمم راسي انا بجيبه. لا هات خلنا عشان نفهم اخف. ما يبطل مش عشان ما اخف هات. بديش اكله اعطيني الورق. بدرتش عليه لا بدرتش عليه. تراي ما ينظف صح؟ خلط كامل. ما يا عمي ما بزبطش لا ما بزبطش لا والله ما بزبطش انا اقولك ما بزبطش. انت عارفه وين الوخر مش عند دوار الوخر. وخفيف ما هو خفيف. بالعنق اذا ما خفيف وين الشعر؟ كيس الثاني كيس. ها كيس الثاني كيس. ها كيس ها. انت والله لو بهنك من المجمع اجي والله والقران ما بتقول. ليش ما كنتش تجيب من السوق يعني وتجيبها؟ ما هو هاي مش اسمها هاي مش اسمها عزتي والله انه بس انت هيك انه والله حق لما تقعد تسولفوا قدام حدا والله اني والله لا انا مسكين والله بروح باجي على المجمع نفسه بحط لي رقمك لا والله هيك تقول عشان قدام الناس لا اني ها والله والله حاضر حاضر انت لا رقمك لا. لا بديش انصح يعني. لا والله مش طلع. طب دفاين انت مستقله وين والوهاب اروح مشوار مشي. كنت اشيل كنت عند دوار البلد اروح اطحن. هذا عند الوهاب. تشيلش خمسه تربطينا خمسه وتشيلينا. هات بشيل كم لابد. هات لابد والله. كلكم ما كنا نمشي كلنا. كلكم. الشاي بالجر يلا. عندك شباب جراوة ها ناس متعلمة ناس واطية يركب سيارة طلب ناس متعلمة تطبخ الحيوانات يعني خلاص بدها تطلع زيت فلسطينية تطلع لازم تستعملها في شيء خذها معاك حتى تجي عند الدكان يقول له وين مروح يعني شدوه وين مروح المدام بكره الجمعه مليح وانا مروح كيف بدي ادفع له ما لقيتش انا كيف بدي ادفع له 5000 بدي اتحمل طيب ليش شدة ايوه هاي المشكله بعدين خذ طيب ماشي توكل على الله خلينا نتحمم هسه خلينا نتحمم دقيقه خل سرور شو تحط على الشحن الحمير مثل البقر الله يلعنك
The only person in this conference.
المقصرين بس أو خلي بس إذا سولف لأنهم ساكتين أبصر بجوز خلص ومش داري غريب 4 ساعات ونص بعده